Hello students, we'll go with the next type of problem in harmonic analysis. Here the question is, the following values of y and x are given. Find the Fourier series of y up to second harmonics. Here we have been given x and y value and we have to compute up till the Fourier series up till second harmonics. Now second harmonics means what all is required? We are required with A0, A1, B1, A2, B2. Okay, so to start the problem, here we have to write first the interval. What is the given interval now? If you observe, all the x values are arbitrary here. Your given interval is an arbitrary interval ranging from 0 to 12. I told you in the previous of my videos, it may be divided into 0 to 6 or 0 to 12. So if more than 5 or more than 6 values are there, then it is understood it is in the range 0 to 12. So we are given with the interval 0 to 12. Here x is taking the value 0 and it is taking the value 12. So it is a closed interval. I have written less than or equals to. Means it is a closed interval which will be written in the square brackets. Okay. Now, since your given range is arbitrary, we need to compute for L value. So before I start to compute L value, if you observe the table, whenever it is a closed interval, means it is taking the end values, that is 0 and 12. That time we observe that the corresponding y value at x equals to 0 and at x equals to 12, the value is going to repeat. That is, it is becoming periodic. So what do we do? When it is a closed interval, means when it is taking the end values, that is starting value and the end value, that time y value gets repeated. In such case, we try to omit the last reading. As per the given, how many readings are been given? 1, 2, 3, 4, 5, 6, 7. When you are counting, you are getting 7. Means n is 7. No, when you are calculating for the table or calculating for the coefficients, that time you have to take n equals to 6, because we are going to omit this last reading by the property of periodic function. When it is taking the end values, that is 0 and 12, that time the value is getting repeated. In such case, we are going to omit the last reading. A very important note over here. Okay, so as per that, n is 6. Since it is arbitrary, we are going to compute for the L value. So it is a full range series. As they have said, till second harmonics means we are going to compute for A1, B1, A2, B2 also. Right? So it is a full range series. So take 2L is equals to upper limit minus the lower limit. What's the upper limit? It is 12. Lower limit is 0. So 2L is equals to 12. So L is equals to 6. As I have told in my previous videos, if your given values are arbitrary, we have to change the values in terms of angle. So we need to convert this arbitrary values in terms of angles. So now how to convert? We are having theta is equals to what? Pi x by 6. L. So what is theta is equals to? Pi x by 6, because L is 6. Now my table will be like this. In this manner, I'll be preparing by writing x value as per given, converting this x values in terms of theta, which is theta taken as a substitution pi x by 6, y value they have given, and we need cos theta, sin theta, cos 2 theta, sin 2 theta, which can be omitted. These lines, this whatever columns I have calculated can be omitted. Directly you can compute for these columns. That is y into cos theta, y into sin theta, y into cos 2 theta and y into sin theta. Directly we can compute. So as per in my previous video, I have shown you how to prepare for the table. Once we prepare for the table, we have to take the summation of y cos theta, summation of y sin theta, summation of y cos 2 theta and summation of y sin 2 theta. Once we prepare for the table, we are going to compute for A0, AN, BN, B1, A2, B2. So as per the formula, A naught is 2 by n summation y. N is how much? 6. Summation y from the table we are having 128.9. So we are getting A naught. Likewise, we are computing for A1, B1, A2 and B2. Hence, my Fourier series will be given as, now here it will be theta. We were taking here cos x and sin x, but now arbitrary values have been converted in terms of theta. So you have to take A1 cos theta plus B1 sin theta. Here A2 cos 2 theta and B2 sin 2 theta. Substitute the values, that will be the Fourier series for the given data. Thank you.